Okay, now we're given an equation of motion. Y equals -6 times the cosine of 3 pi over 4 times t. We're asked to find a description of the motion. Part B, the maximum displacement from rest. Part C, the time for one complete oscillation. Step D, Part D, the frequency. Solution, let's go with Part A first, where we're searching for the description of the motion. Well, A is equal to a -6. So if it's a negative, that implies that we start our motion in a position that's stretched, not compressed. And also, y is equal to a times the cosine of omega t. Okay, so we know something just because it started at cosine. That implies the object starts at a maximum displacement stretched. A equals -6. So what do we know? We know that this object, this particular object, starts at a maximum stretch, A equals -6. Now, you might describe it a little differently. The book might also, but this is where we get the information from the A value, from the cosine, the fact we're using cosine. Part B, max displacement from rest. Well, we just said it. The max displacement from rest, absolute value of A is equal to the absolute value of -6. It's equal to +6. It's always going to be a positive number because we take the absolute value. Part C, time for one oscillation. Time for one oscillation, that's what we call the period, the time for one oscillation. Okay, well, we know, let's see, y is equal to a cosine omega t. In this case, y equals -6 cosine 3 pi over 4t. Okay, so the period t, omega is 3 pi over 4. And we know that the time for one oscillation is called the period t. And we know that period t is defined to be equal to 2 pi over omega. Now, we have omega, so t is equal to 2 pi over 3 pi over 4. Divided by 3 pi over 4 is the same as multiplying by 4 over 3 pi. Simplify, you get 8/3. So the period, the time for one oscillation, is 8/3 of a second. And I don't feel any need to simplify that. That's fine. Okay, frequency. Frequency is the reciprocal of period, so it's 3/8. The frequency of this motion is 3/8 of a cycle every second.